name's Dan Hutchings. I did teach out here for 10 years. It was some of the best times of my life. And one of the reasons why it was so rewarding is interfacing with students. You know, you watch students, and when they're learning a subject, right, you just can watch almost the mental process going on in their head, and then all of a sudden the eyes light up, right? That aha moment we all talk about, where the light bulb goes off. And one of the most rewarding things in my career. So I'm currently a senior network engineer at Cache Valley Electric. We're one of the largest Cisco resellers in the Western United States. We recently won some prestigious awards you guys probably don't care about and everything, but before that I worked in an environment for Rio Tinto and Kennecott. Now most of you, if you look west, you see a big pile of rocks, right? And some of you may have heard like there was a slide, it changed the business. Rio Tinto is the parent company. Most people think it's the actual soccer stadium. They own RSL. No, it's just sort of like the Delta Center from old. I know I'm dating myself, the Delta Center. Right, they were just the corporate sponsor for that. So during my time at Rio Tinto, I got heavily involved in industrial networking and its applications. Now, what the presentation is today is starting along. Wow, some of you really look young in here, so I'll try and fill in the gaps of what's happened probably around the time you were born and date myself at the same time. And then I want to come up to a present day, right? Present day, this is a very, very, very exciting time in a lot of different fields around technology, right? And we're going to take a snapshot as to what we're calling the Internet of Things right now, what that looks like from many different aspects. And I understand some of you are business students, so one of the aspects that we'll look at is a business aspect of that. We'll definitely look at the technology aspects of that too. Okay, Y2K. Anybody remember? Anybody alive for it? That's great. Okay, so what was the problem with Y2K, right? You remember the hype, the hysteria, the letdown, right? Every prepper was just totally bummed out, you know, January 1st, 2000. Very good, Marissa. There was a time, at the time, right, memory was incredibly expensive, okay? Memory on processors, memory, just memory, as you may know, a random access memory within a computer. And so a lot of the early code had to be written tight, compact. And so when we had a date, right, it was taking up less space in memory to store it, the year as a 2-digit format. So just like Marissa said, all this was great until 1999, went to the year 2000, which if you're only storing the last 2 digits, would not be 100, it would be 0. So you would have negative time or time travel or however. In the end, not much happened, but the media events leading up to it, I mean, they depicted kind of what you saw in the commercials, right? Right? So at the time then, there wasn't a lot of significant change going on, right? Think about the networking of computers around 2000. Any of you remember 2000, year 2000, you have a Pentium machine, maybe 512 meg RAM, right? Your cell phone probably has more processing power right now than what it is, okay? Hold that thought as we start moving forward, okay? Now, why didn't we see in the year 2000 all of the things depicted that were in that video that the media got a hold of and they went wild about, okay? Why didn't dams release all their water and wipe out cities? Why didn't the power grid fail? Why didn't all these mass things that computers were somewhat involved with, why didn't all that happen? Well, you might say, well, Aaron indicated that they're all based off of machinery, and at the time that was absolutely correct. Well, if you went looking for a traditional computer, what you found was more PLCs, or programmable logic controls, and they were all system-centric. They were just there controlling function and purpose of that system. So when you looked at all of the compute devices that were on controlling the power grid, they were specific to the power grid. They weren't accessible from outside the power grid. Okay? Same with a lot of other infrastructure like water and pumps and everything. Okay? And I want to make one point here that we're going to touch on a little bit later. Okay? When you have all of these devices out there that require human intervention, right, or a human to operate, okay, you are putting a human there at the source in order to operate it. Okay, so one thing that does is require physical security to protect the device. Okay, physical security meaning doors, locks, barbed wire fence, etc. Okay, so I just wanted to bring that point out because we'll touch on it a little bit later. Okay, but then we start getting into automation. Okay, a computer is a great device. It can do a lot of things. Well, as we start applying some of the traditional computer functions to a PLC, we start having automation. Okay, now a PLC is responsible for such things as like controlling water flow, right? If you've seen any of the movies that were based on Stuxnet, which we'll touch on a little bit later, like Black Hat, the movie Black Hat, right? Pumps. I think in that movie they melted down, or they were trying to melt down a nuclear reactor in China. Okay, and how did they do that? They got a hold of the PLC, and then they changed the code in order for it to do nefarious things. Okay, so automation from the year 2000 starts to become more and more and more prevalent. Okay? And with automation, we can start to do a number of things. Okay? From a business standpoint, right, we take liability for workers being hurt. We take the worker away from the machinery, right? So there's a cost savings there. From a technology standpoint, right, we can centralize how all this is being controlled. Meaning I don't have to have a person standing next to it physically operating it, right? Increase the flow, he said over the radio. Okay, and then reply back, we are now at this %. It can now be done with a PLC, and it can be done without a human there, right? So think about how that technology has changed the workforce. Okay? And along with the changing of the workforce, we are not necessarily in need of somebody standing there doing a manual process. The workforce at that time becomes much more educated, or the requirements for them, right? They are probably college degreed, have experience in a lot of different technology aspects, as well as the specific industrial application. Okay? So safety is obvious, right? I want to show you sorry, I'm not supposed to walk in front of there. On the right-hand side over there, I wanna show you a video related to that. That is a crusher at Kennecott. These are giant spinner. What they do is they feed rock in there, and they have giant metal balls that basically will turn over and crush the rocks. As the rocks come out at a certain size, they're lifted off by a vacuum, much like a Dyson actually. And then they put that in a slurry, water, and then they start treating it chemically to separate the water, okay? As you probably heard, right, it was a very, very loud environment on there, okay? So let's revisit some of this, okay? A worker is not standing next to that, okay? What risks did the worker face when they were? Absolutely, right? Moving machinery doesn't differentiate, human from rock, okay? What about if we took controlled mechanisms, right? We put up gates and other physical barriers to keep a human safety. Is there any prolonged danger about being out there? What was that? Exactly, right? That is a very, very loud environment. So prolonged exposure to there, you are, over a number of years, you are prone to hearing loss. My wife says I developed selective hearing loss from Kennecott, but that's another story. Cost savings start to become very beneficial to very beneficial to a business. For a lot of businesses, what is the number one reoccurring cost? Salary and benefits. To be competitive, to attract the talent, right? Because we've shown that now you have to have a more educated workforce in order to employ them, okay? Well, there's also a demand out there that is, there's more demand than there is workers. Let me tell you that. So, with that in mind, as an employer, right, from the business side, from an employee perspective, how do you attract good talent? Salary and benefits, okay? So, if you look at the requirements of a workforce, if you can eliminate, that's not the politically correct term, if you can transition people into more technical roles, you can reduce your overall cost within a business. Does that make sense? If you can replace 5 workers with 1, you can pay that 1 worker more and still have a total cost savings within the business. Okay. What are some other benefits of automation?
You don't have to train them.
Okay. Exactly. You don't have to that reoccurring cost of workers coming in, workers going out, and bringing a worker up to speed while you're paying them to learn in your environment. Absolutely. That's a good one. What was your name?
Bryce.
Bryce, that was very good. Any other thoughts from a business or technology perspective on that? Yes, Marissa.
Do you get more efficiency, less errors and stuff with automation?
Absolutely. And what was your name? Sakri? What? And you said safety or?
There's risk involved when you're pushing, right? So if it's automated,
You remove the worker, you remove from a business perspective, you remove the liability, okay, and the potential for that. Absolutely, those are 2 very good things. To Marissa's point, a machine doesn't get bored, okay? If in a process you had to do the same thing over and over, and that was your job to do that 1,000 times a day, I don't know, I'd lose my ever-loving mind. Yes?
So you say all the good thing about the machine, but I don't know, the thing about the bad thing is like, if the machine took all the human job, we're gonna be like, no job,
That's a very, what was your name?
Tang.
Tang brings up the point, well, if you remove all of the jobs, right, all of those manual labor jobs, right, we're going to create a problem in the workforce. And that's something that's why I was careful with the words I was saying, but you're absolutely right. That's why I'm talking about a change in labor, right? It's not necessarily that we are eliminating all those jobs, it's that the requirements of those jobs are changing to be more technical, right? But you're right, there are fewer jobs to be had. Okay. See the engineer over there? They posted that on my office door one day. The funny thing is I was doing a month-long project up in Wyoming, and so I didn't see it. So it became well known to everybody in the office but me, right? There's a traditional engineer, well, anything industrial they send me to do within the company anyway, but anymore, right, what is perceived as a blue-collar worker has become heavily white-collar work in that field, right? But you still wear a hard hat and safety glasses. But to Tan's point, right, a lot of those more manual labor jobs are going away. And so they're being replaced with jobs that require more education, more know-how, especially in the technology realm. All right. And centralized control was another thing that I mentioned earlier that I really wanted to touch on, okay? You take a PLC, right, programmable logical controller, and it was in a specific place doing a specific function, okay? And when it needed to be manipulated or whatever, you had to physically go out to that location, okay? So they're somewhat temperamental from time to time. You have to go out and physically touch them. But now, what happens if we make them accessible over a network?
You don't have to go to them. They're right.
Exactly. Okay, so from a technology standpoint, what are you doing? You are increasing a lot of critical network function, okay? In a traditional IT realm, what happens if the network goes down? Well, most people think, oh, my phone, I can't make a phone call, right, with a voice over IP phone. I can't get to my email. Boo frickin' who, okay? What happens in an industrial realm when the network goes down? You stop the business flow, right? We had a saying at Rio Tinto, we don't stop the dirt from coming out of the ground, okay? That to say, right, I've done a lot of work on the electrical grid, and I've done a lot of work in oil refineries as well in my current role. Pacific Corp has a similar saying. We don't stop the electrons from flowing. Okay, in the oil realm, right, we don't stop the oil in the pipelines. And why is that? Because when you do that, you stop the business from making money, okay? So there's a lot of business processes around technology. It is no longer an inconvenience. It is a business function that is to the detriment of the business, okay? Now I want to give you an example. Over on the right-hand side there, you see a man walking on what is beneath there, a giant tank of acid, okay? It's true. He is walking on anodes and cathodes that are giant copper sheets, okay? What is happening there is they put a tremendous amount of voltage across it, right? And it's in the whole purification process. And if you want to understand that better, I really suck at chemistry, to be honest. But it's taking after a smelted piece of copper, right? We are increasing the purities by pulling them out with electricity, a large amount of electricity and chemistry. Okay, the electricity induces a chemical change. Okay, so he's walking across there. Now, what you see over here on the right-hand side is what everybody referred to as the stripper. There's a lot of childhood humor that you could have with that, okay? So what I want to bring to your attention is over on the upper, let's see, looker's left, upper left-hand side, there is a railway that comes, okay? It comes over and drives it over to the stripper. There is a process in which these copper sheets are lifted out. It goes somewhat in a carousel, and they are separated. That is automated, and then over here on the upper looker's right, you've got where they come out in somewhat of a palletized form, and then they are loaded either onto a rail. Kennecott shipped a lot by rail, or semis, but they're all driven around by forklifts, okay? Now, some of the dangers associated with this, right? Well, there's the electricity and acid we mentioned that he was walking on, okay? If you have operators around a lot of machinery, obviously you're putting them in harm's way, either from a short period of time or from a long period of time. So what we did is, and I have to be careful with what I say on this. I can't divulge anything that's not publicly available because of a non-compete I signed with them. But they have no pictures posted of the railway, but there are plenty out there that exist, okay? So these are automated cars, and you can see that this one has a bright yellow line. Technologies have emerged so that you can have a device with wheels, whether it be a rail car, whether it be a forklift or whatever, follow patterns through cameras and analytics, driving themselves around performing functions. Okay, I did some work out at Dan and Yogurt. Their packing facility, they would have a refrigeration unit, and these giant machines would come around, lift up a pallet, go, and then take it out to where the semis were and everything, right? Driving themselves, okay? We are not reinventing everything. Obviously, there is a PLC on the device doing it, but how do you get network connectivity to the device?
Isn't it through the rails?
That's how it gets electricity to it. Network connectivity.
Let's go through those cables.
I think those are actually just power cords. So I'll give you a hint. You guys probably use it every single day, not even think about it anymore. Wi-Fi. Little known, unknown fact. Any of you IT students in here? Sort of? Okay. Salt Lake Community College at one point had the largest wireless network in the state. Yes, it's true. They were early adopters. We had a president at the time that was really forward thinking, and so he went out and purchased a bunch of Gen 1 access points from Cisco. I believe there were 351 of them deployed, and about at any time you would find about maybe 10 or 12 people on the wireless network. By the way, it had one broadcast domain, if that means anything to any of the technology students in there. Yes. So it was working just fine until we actually got a significant number of users on it, like around 40. Okay. Now we're replacing them. It looks like you've replaced them with a bunch of upgraded Cisco access points. That one on the ceiling is probably a 3x3, meaning it's actually got 3 radios in it, that one access point, whereas we were only deploying single radios in the beginning. What was your name?
Sharon.
Sharon, great. Wireless. Wireless is a good way to do it. So if we place on one of these cars a wireless access point, then we can get connectivity to all of the PLCs on there. Now the PLCs are controlling, okay, I am at this location. And they can do it either by lasers and mirrors down to a millimeter, or they can do it as I need to stay on this yellow line, and now the yellow line is turning, so I need to turn my wheels as well. Okay? Then the car is free to move throughout a wireless network as long as it has connectivity. Okay? There's also, for some of you other technology students or the business students from a development cost, right, the PLC is driving the function of it. Anybody see a problem with a car driving itself?
It can break down. malfunctions and
Ethics issues? What was your name?
Price.
Bryce, what do you mean by ethics issues?
Well, if the car knows it's going to get in an accident and potentially kill somebody in front of them, and the only option is, I guess, veer to the right, but there's somebody on the sidewalk, it has to make the decision on which is more, just make the decision on what's safer or what's the right thing to do. Kill the one person in the car
Or the single person on the sidewalk. Okay, so what Bryce was saying is, if you've got and I'm going to genericize it somewhat, so let me know if I'm misrepresenting what you're saying. If you have a device headed for a catastrophe, right, whether that be loss of human life or loss of other life, if it has to make a decision, right, does it make the decision for a single life or multiple lives? Is that a fair?
Yeah.
Let's genericize that a little bit more, right? What happens is you start to drive this machine towards a gas line. Okay? Not only from a business standpoint are there huge liabilities at play, right? There's obviously huge safeties at play. So a lot of the design around all of these things is from a do no harm first perspective, right? If you run into anything, the best result is to stop. Okay? Another aside from the business aspect of it is you can look at it from an entire process. Okay? In order to access this machine, you have to do certain procedures. Those procedures basically take the device from a state where it could hurt, potentially kill, to an inert state where it's not going to have any negative effect. Okay? So now we've got a rail car driving back and forth on it. Here's another example of one. This is on a turnstile. It will actually come into a turnstile and then make a 90-degree, sometimes spaces of a premium. Ours just drove back and forth. But then what we were doing is we were taking, and a crane would come over and pick up, it was like 2 or 3 tons of copper at a time with these copper sheets. Put them on the rail, and the rail would just drive it over to where we were with the stripper. The stripper would lift them out, strip the anodes from the cathodes, bundle them, ready to ship. Okay? Total improvement process. Took out a lot of operators. Saved the company a lot of time because now they could put their forklift drivers on an 8-hour schedule rather than staffing it 24/7, and they would just come in and there would be copper that needed to be moved. Okay? And then here is a look at what the finished product was. These are metal binds around there, and just a bunch of raw copper that they shipped out. Mel brings up a great point, if I misrepresent, just speak back out. If you have somebody there that has to service the machinery, service all of this, what is the business trade-off of having that person not be there versus downtime or the total cost to get the product out the door? Is that a fair? So in answer to your question, you have to look at what is all the machinery doing. Okay? Back through our process, okay, where they're going to the strippers, it was a manual process before. We had a driver in the crane, and they started replacing the cranes when I left, which was shortly before the slide out there. So there was a driver in the crane. Okay, there was somebody who was driving the rail back and forth, and then there were people actually at the stripper, basically running the processes through. It was a manual process of, okay, I've got load, now I need to do these things with this load coming through. So machinery was still very much a part of all of that. And with the machinery being very much a part of that, you still have the physical wear and tear on that machinery running. All we did is provide an interface so that the person didn't have to be there. Does that make sense? So the operational, in specifics to your question, the operational cost for that equipment was still present. Okay? Pumps. Pumps are a great example that most people are familiar with. Like you drink water, right? It came from a pump somewhere. That pump running has got a certain number of hours that it can run, or that it's rated for, over a period of time at certain pressures. If it falls out of maintenance and some of the internal workings of the pump start vibrating on one side, that number of hours is degraded significantly. One other advantage of automating is we get the data. So we can put sensors on it and say, whoa, right? If we purchase this piece of machinery knowing that it would operate 500,000 hours, okay, but improper maintenance or early parts breaking decrease that by 20%, right? If we have an early detection system, we are protecting our investment on that 500,000 hours. So it also helps even out operational costs. That's a very good point, Mel. And here was a final picture of the stripper, just bigger. PLCs, okay, programmable logic controllers. We've talked about them, but I wanted to show you some pictures of some. PLCs have become, right, they basically, every sensor and everything wires into the device over on the looker's left, right? And they are the ones that control everything. But it's a system of PLCs working together that define a process, right? It is not good enough that one PLC controls a pump. You need a system of PLCs to control a flow of material. Okay, does that make sense? So think of it as a system of things communicating across the network to control an entire system, whether it be the power grid, whether it be oil or flow or anything else. Okay, Internet of Things, right? We're talking IoT. If you're IT student, you're very well versed in your FLAs and your TLAs. Yes, your 4-letter acronyms and your 3-letter acronyms. Okay, real quick, we're going to look at what a quick definition of Internet of Things is.
By now, you may have heard the term Internet of Things. Sounds interesting, but what does the Internet of Things actually mean? IoT is an evolution of mobile, home, and embedded applications that are being connected to the internet, integrating greater compute capabilities and using data analytics to extract meaningful information. Billions of devices will be connected to the internet, and soon, hundreds of billions of devices. As related devices connect with each other, they can become an intelligent system of systems. And when these intelligent devices and systems of systems share data over the cloud and analyze it, they can transform our businesses, our lives, and our world in countless ways. Whether it's improving medical outcomes, creating better products faster with lower development costs, making shopping more enjoyable, or optimizing energy generation and consumption. Here's an example of the big picture. Imagine an intelligent device such as a smart traffic camera. The camera can monitor the road for congestion, accidents, and weather conditions, and communicate that status to a gateway that combines it with data from other cameras, creating an intelligent citywide traffic system. Now, imagine that intelligent traffic system connected to other citywide transportation systems, which get data from their own intelligent devices, creating an ever larger intelligent system of systems. The really big possibilities come from analyzing the end-to-end data across that system of systems. For example, let's say the city's intelligent traffic system detects massive congestion due to an accident. That insight can be sent to the citywide transportation system, which can analyze the accident's impact on other city systems. Recognizing the accident is near the airport and 2 city schools, it could notify those systems so they can adjust flight and school schedules. It can also analyze and derive optimal routes around the accident and send those instructions to the city's digital signage system to guide drivers around the accident. And that's just one example of the potential benefits that can happen when intelligent devices share insight with other systems, forming ever-expanding systems of systems. But how?
Okay, so I wanted to bring that to your attention, and then in the interest of time, we're going to look at really something that scares the heebie-kajeebies out of everybody in the field, okay? So going into this, know that there is all these devices accessible across the internet, right? Internet's just a giant network that connects everything. Stuxnet is basically a virus.
In June last year, a computer virus called Stuxnet was discovered lurking in the databanks of power plants, traffic control systems, and factories around the world. 20 times more complex than any previous virus code, it had an array of capabilities. Among them, the ability to turn up the pressure inside nuclear reactors or switch off oil pipelines, and Stuxnet could tell the system operators everything was normal. Unlike most viruses, Stuxnet doesn't carry the usual forged security clearance that helps viruses burrow into systems. It actually had a real clearance, stolen from one of the most reputable computer technology companies in the world. It exploited security gaps that system creators are unaware of. These holes are known as 0 days, and the most successful viruses exploit them. The details of a 0 day can be sold on the black market for $100,000. Stuxnet took advantage of 20 0 days. But once it got into a system, it didn't always activate. Buried deep in the Stuxnet code was a specific target. Without that target, the virus remained dormant. What was it looking to shut down? The centrifuges that spin nuclear material at Iran's enrichment facilities. Stuxnet was a weapon, the first to be made entirely out of code. The Washington-based Institute for Science and International Security says the virus may have shut down 1,000 centrifuges at Natanz, Iran's main enrichment facility, last year. In November, the International Atomic Energy Agency, the UN's nuclear watchdog, said Iran had suspended work at its nuclear facilities without explaining why. Many observers credited Stuxnet. Last month, the Iranian government conceded the virus's infection of the Bashir nuclear facility, still under construction, meant that switching the plant on could lead to a national electricity blackout. Iran has responded to the attack with an open call for hackers to join the Iranian Revolutionary Guard and has reportedly amassed the second largest online army in the world. So who was behind Stuxnet? There's no evidence beyond rumor. Some have it that Israel is responsible because the virus code apparently contains references to the Hebrew Bible. Others believe the US was involved in the testing and development. The finger has even been pointed at Siemens mobile phone company, whose software is used by the Iranian regime. The most important question may not be who designed it, but who will redesign it. The evolution has been so fast that 9 months after its detection, the first virus that could crash power grids or destroy oil pipelines is available online for anyone to download and tinker with. You can watch people on YouTube pulling Stuxnet apart. It's an open source weapon. And there's no way of knowing who will use it or what they will use it for.
We have two worlds colliding. We have an industrial realm which is very controlled in a lot of different aspects, okay? Slow to change, slow to adopt, slow to affect their business process. We have an IT realm that is very quick-paced, very fast, very inventive over a short period of time. And we have the security world of both of them with major consequences and applications coming together, okay? This is the world in which we live. There's a lot of different books out. Not all of them are doomsdays. There's one called When the Lights Go Out, or Lights Out. Everybody should read it. It's the stuff that keeps, when you're working in the field, it's the stuff that keeps you up at night. One might argue if the lights were out, you might sleep better. Okay. So from a technology standpoint, right, or a business standpoint, there is a lot of data being collected. So there's a lot of data analytics applications. There's a lot of IT applications. There's a lot of security applications for anybody who is interested in the field. So you guys are, regardless of your respective areas in here, you're making a wise educational decision. So.